Hello friends, this is going to be just a real quick video about how to calculate wavelength and frequency for light waves. Let's hope it goes smooth. So remember, frequency is the number of wave crests that pass through a given point in a given unit of time. And that frequency, given by the lowercase f, is equal to 1 over the period, or the amount of time it takes for the wavelength to pass. So the unit is hertz, given by Hz, and it's equal to 1 per second. 1 per second. All right? So velocity of the speed of light, we always give velocity as v, except in this special case with light. And for light, we use the lowercase c. And it's equal to 2.99792,458 times 10 to the 8th meters per second. We will use 3 times 10 to the 8th meters per second in our calculations, just to simplify things. Right? And velocity is equal to lambda, or the wavelength, over the period, or we're trying to find how fast a wave goes in so many seconds. So this is a speed. It's a distance over time, or distance over time equals rate. Remember that formula? D equals R times T, distance equals rate times time. Well, now we're just solving for R. And to solve for R, it's just D over T. All right? And that's all we're saying here, is the distance over the time is equal to the velocity. Or in this case, C is equal to lambda divided by the period. But because frequency is equal to 1 over the period, we can simply replace this with C is equal to lambda, or the wavelength, times the frequency. The frequency is 1 over the period. So this is the same as saying 1 over the period as F. You just replace it. Simple stuff. Simple stuff. So if we want to calculate the frequency, can you see this okay? I feel like I should bring you in. Come here. Come with Mr. Britton. Let's go over here. See if this helps a little bit. So frequency, let's say we want to calculate the frequency of red light with a wavelength equal to 743 nanometers. Now you have to remember that a nanometer is 10 to the negative 9th meters. So 1 meter, or 1 nanometer, is equal to 1 times 10 to the negative 9th meters. So you can either convert your nanometers, or you can convert your speed. So to find frequency, we're going to say C is equal to lambda F. We divide both sides by lambda. The lambdas on this side cancel, and we get frequency is equal to C over lambda. So we just calculate then and say 3 times 10 to the 8th meters per second divided by 743 times 10 to the negative 9th meters. Our meters cancel. We're left with 1 per second, or hertz. And And when you divide those out, you should get a frequency of 4.037685061 times 10 to the 14th hertz, or 1 per second, just like our unit would be here. Fair enough. Now, if we want to calculate the wavelength, you just solve the other direction. Let's move down real quick. Sorry if that's making you dizzy. My apologies. Last one, real quick. So again, we go back to C is equal to lambda F. Solve for lambda, so you divide both sides by frequency. So we get lambda is equal to C over F, or the speed of light divided by the frequency. So if I have a frequency that's equal to 6.0215 times 10 to the 12th hertz, I can find the lambda fairly easily by saying 3 times 10 to the 8th meters per second divided by 6.0215 times 10 to the negative 5th meters. Our meters cancel. Yes? No, I'm sorry. Wrong unit. This is in hertz, or 1 per second. So our seconds cancel. And we're left with meters over 1, or meters, which is a length, just like we'd want our wavelength to be. So then we just divide, and we get lambda is equal to 4.9826 times 10 to the negative, put the wrong number here, to the 12th. See, look at that. I copied my number wrong. So you got to watch that stuff. That'll mess you up every time. It's little things. Always double check your work. There's your proof, because your answer should be to the negative 5th meters. So I hope this helps. If you have any questions, let me know. And hopefully I'll talk to you sooner than later. Take care, friends.